Hey everybody, how's it going? Today we're going to do an experiment called Magic Milk. Now let's get into the video. And so welcome to our Magic Milk experiment. And let's start off by talking about a couple of things we have, the materials, and of course Magic Milk would not be milk without milk, which we're actually going to try a little half and half cream. Now fattier should be better, we'll see. You need soap. And we're going to do it two different ways. We're going to do it with Q-tips, and we're going to do it with cotton swabs. And last but not least, the thing that gives us the cool tie-dye effect, the food coloring. All right, so you start by putting a thin layer of milk in the plate. Now, I first read to do about 2.5 centimeters, but I think a little bit less is actually going to be more. Now, once we've laid out our pattern, we're going to get our Q-tip and we are going to dip it in the soap and just drop it in there, and what happens? Oh! Isn't that interesting? It's like it's being pulled towards it and pushed away from it all at the same time, all at once, creating a interesting tie-dye-like pattern. And wherever you can see, it really messes up the food coloring, it would appear, is reacting. Now you might say this is a chemical reaction, but actually it's not a chemical reaction. We're just exploring the physical properties of matter. There's no new colors being formed here. There's no smoke or light or heat being given off. However, the physical properties of fat, which is the milk, and water, and especially soap, cause these interesting interactions, this swirl, this tie-dye-like pattern. Now my assistant's just mixing it all up. There's no physical properties are making that happen, no forces. But it does look really beautiful. Okay. Let's try it way number 2. So we'll put that away. Goodbye. And this kind of looks like the world a little bit, like a globe or something. The planet. It looks like art. So we're going to do the same thing. Step 1, thin layer of milk. This is not super hard. Okay. Step 2, interesting pattern. Cotton swab. Same thing as before. We dip it in the soap and get it nice and juicy in there and just drop the bomb, the color bomb. And you can see it's kind of being pulled towards and pushed away at the same time. It's a hurly-burly of colors. Look at what's happening with the green right now. The darker green, I should say. Now, we've got some definitely cool stuff going on. We can pick this up and sort of drop it somewhere else, and you get a similar effect. And ooh. And really, all of this is happening because oil and water don't mix. Physical properties of matter. Okay, so what did we just see there? Well, remember I told you those words, hydrophobic and hydrophilic? Well, that's kind of key to understanding what's happening. Now, you might have people tell you that this was a chemical reaction. It wasn't. It was just the physical properties of the milk, the water within the milk, and the soap that made this happen. Now, milk is fat mixed with water. Now, fat is hydrophobic. It hates water. Water is hydrophilic. It loves water. And soap's kind of bipolar. It's both. It's got one side of the molecule loves water and is attracted to it, and one side loves fat and is attracted to it. Now, if all of that sounds like a mishmash, well, that's exactly what happens in this experiment. When you mix the food coloring in with the fatty milk, it doesn't really mix together. But then when you put the soap in, that soap starts pushing the milk molecules all around. They don't know what to do. They don't know to be attracted to it or pushed away by it, and it just causes a ton of movement. Now, that would happen whether the food coloring was there or not. But because the food coloring's there, you see the food coloring streak all over, and it just looks like a fun tie-dye. And I hope you enjoyed that experiment as much as I did. Like and subscribe!